So a lot of security is really, my favorite areas in computer science, but within security, cryptography is my most favorite. And the reason is that you can actually reason mathematically about attackers, and you can provide guarantees against any attacker strategies within a model using mathematics. So that's very, very powerful, because then we can build very interesting systems that provide super strong guarantees. Okay? So it's not just reasoning about, there's an attack and there's a specific fix. No, it's about providing a mechanism that prevents all sorts of attacks at the same time. Okay, so it's a very principled way to go about security. So whenever we talk about cryptography, whether it's in an undergrad class or in advanced research papers, we have some special guests. Alice, Bob. They're usually neutral characters. Then there's the attacker. And the attacker can be Eve or Malice. So Eve usually is an eavesdropper, so she just listens to conversations or snoops on a server, doesn't actively do changes or corruption, whereas Malice is more malicious, so she can actually try to actively change things. And we'll see when we talk about attacker models the difference between the two. And then sometimes Chris shows up too, depending on the protocol. All right, so what is cryptography? So when you look at some of the textbooks, because they're a little bit old, I think they have a bit of a narrow definition of cryptography. They mostly focus on securing communications. So for example, how do you talk to Bank of America online by establishing a secure channel such that Eve cannot see what's on the channel going to the bank, or Malice cannot change, for example, what deposit you're making into the bank or who you're transferring to. Okay, so a lot of the classical definition of cryptography refers to securing communication. But since then, we've done so many more things with cryptography that I view it mostly as a way to provide guarantees in the presence of an attacker. Okay, so generically, any kind of guarantees that you want to provide in the presence of an attacker, cryptography enables you to do that in a formal way. So reason formally about the attacker model, the guarantees you want to give, and then of constructions that can provide security in the face of an attacker. All right, so there's usually a few goals that we target with cryptography. So one is confidentiality, namely preventing adversaries from reading your data. So you only want users who are authorized to see some data to see it, and no one else should. Another goal is cryptography helps us with ensuring integrity. So this makes sure that an attacker cannot change our data without us realizing it. And third is authenticity. We want to make sure that a message that says it's coming from Alice, it really is coming from Alice and not from someone else. So ensuring that it's really coming from the user that you expect it to be coming from. So there are some goals that cryptography doesn't help you with. For example, availability. Okay, it helps you encrypt messages, sign them, things like this. We'll see what each operation does. But availability is something it cannot help you with. If you drop a message, it's not going to necessarily help you with. Okay, so we're going to study two types of cryptography in class. One is symmetric key encryption, and the other is public key or asymmetric key cryptography or encryption. So the symmetric one basically says that Alice and Bob here, who are communicating over an insecure channel, symmetric key cryptography says that the keys are the same. Okay, so Alice and Bob have to share a key that is the same key and that no one else knows. And we'll see how to share those keys. It's really not that easy. For example, they could meet in person and then they can secretly share a symmetric key, but it's not convenient to always meet in person, right? So you'd like to talk to, for example, a website you've never talked to or you're visiting for the first time, and you would like to have a key shared between you and that website so that you can have a secure channel, but we'll see how you can establish such a key later, okay? So symmetric key cryptography says that the key is the same. In public key cryptography, there are going to be different keys. And so the sender, Alice, has a key, and the receiver, Bob, has a different key. And this will really help us in scenarios such as you go to a web server and you don't know what that web server's key is. Okay, so that it really helps us there. But both types of cryptography are heavily used. So in particular, we use them every single day when we surf the web. Whenever you see HTTPS, and we'll explain what that means, HTTPS is using both symmetric key cryptography and public key cryptography. So these are schemes that you're using every single day. Okay. So before we start delving into how the different protocols are, so we learn in the class how the different tools are, how they even work, how to construct them. But then we're also going to learn what security they provide and how to use them to build systems using them. So in particular, in Project 2, you will build a encrypted version of a file sharing service. For example, Dropbox today is not encrypted. Dropbox can see all your data. But with your Project 2, you're building an equivalent service, of course much simpler, but the cloud is not going to see the files and your data.